The way we're going to operate today is we're going to have 3 presentations, go through them fairly quickly, and then open it up for Q&A. We encourage you to use the chat function, and I will be curating that. In order of presentation, we will start with Sonya Germann from the Montana Department of Natural Resources and Conservation, where she is currently the state forester overseeing DNRC's largest division that fosters responsible and proactive stewardship of Montana's forests and rural lands. We're very pleased to have Sonya joining us today. The second speaker will be Malcolm North, who is a research scientist with the Forest Service's Pacific Southwest Research Station in Mammoth Lakes, California. He also is an affiliate professor at University of California, Davis. He has more than 25 years of research focusing on Western conifer forests and has looked at the whole notion of reforestation and the impacts on the forest ecosystem from a landscape perspective. And then finally, we will have Eric Sprague, who is Vice President for Forest Restoration at American Forests. Eric oversees the implementation of the large landscape forest restoration efforts across North America for American Forests. We're really pleased to have all 3 speakers who will be examining this issue on reforestation from various views. And right now, let's go ahead and start with Sonya. And again, I encourage the attendees, if you have a question or comment, please put it in the chat. Sonya, over to you.
I can just have my colleagues, if you could just let me know if you can't hear me or if my slides aren't advancing. Good morning, everyone. Thanks for the invitation to be here to talk about reforestation. And like Ann said, my name is Sonya Germann. I'm the state forester for Montana, and I'm currently in my home office in Missoula, and I'm gonna be showing you a number of pictures today of the beautiful landscapes of Montana. Just really appreciate the opportunity today. So we're all looking to our forests to provide climate solutions, important wildlife habitat, clean and abundant water, forested recreation opportunities, and goods and jobs to develop and sustain local economies. Forests capture approximately 15% of US carbon emissions. Carbon is sequestered in soil, living trees, and further sequestered in wood products. More and more decision makers, land managers, private forest landowners, and the public are valuing efforts to retain forest cover. And as we continue to see devastation from large-scale events such as wildfires in the West, the discussion now is more important than ever. I know that we're here today to talk about reforestation, and I would offer this framing for you. Reforestation is simply the recruitment of our future forests and should be seen as an investment in carbon sequestration and the protection of the many other benefits we derive from our forest. Reforestation takes place post-disturbance and often draws more interest from the public and decision makers after large-scale wildfires. While reforestation is critical to maintaining and reestablishing forest cover, it is important to contextualize it. Land managers would say that to retain or recover forests into the future, we need to focus on the resilience of our forested ecosystems. Resilience is simply our forest's ability to withstand large-scale disturbance events and provide current and future benefits for generations to come. Reforestation is not only important to the recovery from disturbances, but its success is dependent on the resilience of our current forests and their ability to provide suitable conditions for the next generation of trees. As Montana's state forester, I bring you largely a Montana perspective, but a perspective that I think is indicative of many forests in the West. And please understand that I'm offering you a small slice of information in what is otherwise an overwhelming field of practice and study. Along with 6 other states, Montana's forests, once important carbon sinks, have now become carbon sources. Over 100 years of management decisions aimed largely at excluding wildfire from the landscape have dramatically altered our forests. This has changed how Montana's forests respond to and recover from wildfires, and ultimately how they respond to a changing climate. Many of the forests that were once dominated by tree species that tolerate fire are now dominated by species that are less fire tolerant, resulting in uncharacteristically dense stands with excessive fuel loads like you see here. This increased fuel loading, insect epidemics, climate change, and drought are all major factors that contribute to increasing wildfire risk in Montana. We live in a fire-adapted ecosystem, and while fire will always play an important and necessary natural role in Montana's forests, the current state of the forest has created a fire-prone landscape more susceptible to high-severity wildfires. Today, over 85% of Montana's forests are at elevated risk of wildfire. Similar to other states throughout the West, Montana's fire seasons are becoming longer and more severe. And more than ever, Montana now experiences mega fires, which are fires over 100,000 acres, and the average fire season is 40 days longer than it was 30 years ago. And now, most recently in California, we are coining the term gigafire, a term used for a fire that is more than 1 million acres. And similar to many states in the West, over half of Montana's forests have been impacted by epidemic proportions of insects and disease. Dead and decaying trees and severe wildfire seasons are some of the reasons why Montana's forests have become carbon sources. Particularly after large disturbances, both managers and the public look to reforestation as a priority to establish the next generation of forest. After these disturbances, seedling establishment and survival are faced with many challenges. Factors like the suitability of the soil, competing shrub growth, drought, immediate weather events, herbivores who think seedlings are delicious, and distance to seed source all influence the success rate of seedling establishment and survival. Likewise, researchers are finding that our forested ecosystems are shifting due to a changing climate. High severity fires can accelerate changes that would take decades to play out under climate change scenarios. This is especially exacerbated at lower elevations where trees grow at their warm, dry margin. Researchers are finding that large adult trees can withstand a broad range of climate conditions that are not suitable for seedling establishment of the same species. When fuels and other conditions are such that a high severity fire occurs in these forests and causes high mortality, the conditions that were once suitable for larger trees are no longer tolerable for a new forest to regenerate. In short, these fires could accelerate the loss of forests at lower elevations. As foresters and land managers, we prefer to let our forests naturally regenerate. That way we know the seed source is site-specific, may have the best chance of survival, and is cost-effective. However, conditions may not always cooperate with our best laid plans. We know that natural regeneration is largely driven by distance to seed source. In areas where severe wildfires have removed these large, what we call seed trees, the chance of seedling establishment decreases. And even when seed trees might be available, strong seed production from those trees may not coincide with favorable weather conditions to allow the seedlings to flourish and survive. That's why many land managers turn to and rely on planting. By planting, we can select the seed source, evaluate the quality of the seedling, and select the best conditions to plant in. Whether natural regeneration or planting, we follow up with on-site monitoring to monitor regeneration success or failure over time. This helps us make land management decisions into the future and helps us understand how seedlings respond to different site conditions over time. With literally millions of acres burning every year, reforestation is critical to the future of our forests. And as state foresters, we are action-oriented, and a few things come to the top of our mind as we think about retaining and recruiting future forest cover. We know we need to scale up the work to reduce the severity of fire and the large-scale loss of forest cover. As land managers, we have things at our disposal such as mechanical thinning and prescribed fire. These tools are effective at reducing fuel loading and have the added benefit of producing jobs, protecting watersheds, and improving recreational benefits and wildlife habitat. We rely on research. We are facing disturbance events and climate change conditions that haven't been seen before. Understanding the dynamic conditions of our forests, particularly in the face of climate change, is critical in helping us understand how to make sound management decisions to retain current forests and recruit forests into the future. As state foresters, we rely on our partnerships to invest in efforts to reforest the many acres that are impacted particularly by wildfire events. Partnerships help us deliver resources in a timely way to plant and monitor our future forests. We know that as a forestry community, we need to continue to invest in the science of growing seedlings and our country's capacity to respond to the need. And lastly, I'll say that our forests are wonderfully dynamic ecosystems, and it will take dynamic solutions to retain them into the future and keep them working for the many benefits we derive from them. Thank you.
Sonya, that was great, and wonderful views to close out your remarks. With that, let's go ahead and turn it over to Dr. Malcolm North.
All right, thank you, Ann. Let's see, can you see the first slide of this, reforestation strategies, and hear me?
Yes, we can. I can hear you, and we can see the slide.
Okay, great. Thank you. Thank you very much for having me this morning. What I wanted to do really is discuss some of our reforestation strategies and whether we need to think about modifying them, or I would suggest just adapting them to a more challenging, changing world. And I think Sonya has given you a great background as to what some of these challenges are. But in essence here, I'm going to cover a topic in which a bunch of us recently got together and put out a paper discussing whether we should think about reforestation, particularly in dry Western forests, with an emphasis on resilience. And I'm going to stress in this talk that the frequency and severity of stressors, particularly fire and drought, suggests that what we need to do is think about reforestation practices in terms of building resilience into these young stands. So a brief recap here of what is often reforestation practices in the Western US in almost all the states in which wildfire is having a really large impact on forest conditions. And you can see that the general trend here in the way that forests are planted in an area after a wildfire is that you have crews come in and often plant trees in fairly regularly spaced lines in which you generate a young plantation, often of a preferred species such as pine, which is what is generally more fire resistant, as well as possibly more drought resilient, more drought resistant, although I'll discuss that later here. But one of the benefits of this regular spacing is that you get very rapid growth in the forest. And because of that, the forest becomes established, outcompeting other species on the site, particularly shrubs. But you can end up with a fairly simplified forest condition, as you can see in that bottom middle slide. It is, however, a strategy which has a lot of pluses to it, and particularly because of the fact that you bypass the uncertain seedling stages, you get rapid growth in the seedlings that you plant, and you get the crowns interlocking to control the light resource, shading out competing vegetation such as shrubs. So why this focus on tree regeneration quickly gaining site control? Well, the problem is that in much of the Western United States, and not only in the West, but in many systems around the world, you have a pretty aggressive shrub community, which often can really take over and dominate a site. As you can see in this upper right-hand photo, about 8 years after the Angora fire, which was a fire in the Lake Tahoe Basin. And so the idea with a fairly high density planting is that basically the trees get a lock on the site and become controlling of grabbing the sunlight and shading out the shrubs. The bottom left shows you a chart for California or Region 5 of the Forest Service as to what the recommended level of seedlings are that you should plant per acre, which is the TPA. And if you look at those numbers and then compare them to the right-hand values for ponderosa pine, red fir, and mixed conifer, you can see that roughly we're planting trees at 3 to 5 times the density of what those trees would have been in the forest pre-European period in which you had an active fire regime. So you're creating a much more dense forest condition with the goal of shading out the shrub community. But unfortunately, unless something is done to reduce the number of those trees, you're going to have far more trees on the site than could be stably maintained given wildfire and drought stresses. And it's really dependent on this system which we've developed over the years, which has been very successful, but requires a fair amount of revenue to implement, which is as you plant heavily, the trees control the site, and then you go in and enter the stands, what I would call kind of course correction, which you thin them out with pre-commercial thinning or PCT. You reduce the competing shrubs with herbicides or grubbing techniques. The problem with these methods is that they're very expensive to do, and the budgets, particularly for large land agencies such as the Forest Service, have been pretty dramatically declining. The problem is if you do not get in and kind of course correct these stands, you end up with mature plantations like that photo I was showing you that basically lack spatial and species heterogeneity. So it raises this question of, are our reforestation practices in these fire-dependent forests the best for producing resilient forest conditions under more challenging futures, which are going to involve more extreme wildfire and more extreme drought? And I'm going to suggest that there's some reasons why we should rethink some of these approaches. The first problem is that you have, when you're planting what foresters themselves will call pines in lines, you have a pretty uniform spacing. And if you look in the upper right, you'll see that one of the interesting things that research has really uncovered just within the last decade is the tree pattern really matters. We know that if we reduce fuels in the forest, we can reduce the intensity of wildfire. But we've recently found that what you need is these gaps in the forest where you have openings as well as clumps of trees, and that is a significant influence on reducing wildfire intensity. If you have a regular pattern of planted trees, you lack those gaps and reduce the wildfire resilience of the forest. The other thing that's going on, of course, is that with uniform distribution, you have the same kind of competitive environment for each seedling. The bottom right slide shows kind of the sense of when you regularly plant trees that you don't have a lot of variability in the competitive or resource capture area for each tree. In essence, you've kind of put all your eggs into one basket. And once the forest dries out enough during a drought that exceeds how much water that competitive environment around each seedling can uptake, then you're likely to get a crash of just about all the seedlings at once. The other reason to be somewhat cautious about this is to think about the fact that any forest you walk into, you will, if it's a natural forest, you will not see it in a regular crop production planted pattern. In fact, what you will see is this photo in the upper left that shows what a natural forest looks like with an active fire regime in Yosemite National Park. And the thing to note is that you have this fairly complex spatial pattern of openings, clumps of trees, and scattered individual trees, which is what research is really suggesting is a very fire resilient type of structure. If you're planting pines and lines, you're going to have a hard time getting to this kind of structure unless you go back in with chainsaws or modify the density to kind of create this kind of pattern. So we're starting to suggest of thinking about planting in patterns in which you're taking advantage of variability in the natural resources. And for instance, planting groups or clusters of trees in wetter sites and planting individual spaced out trees in the drier areas in between those wetter sites. So trying to match forest conditions to the availability of resources. Let's bring the forests in sync with how topography controls both soil moisture and fire behavior on a site. The other reason to consider this technique about best crop production, does it equal resilient forests, is that it also has this problem of generally a lack of species diversity. And an interesting consequence of this, which we really got kind of kicked in the butt by in California, was that we had a pretty significant drought between 2012 and 2016, which we generally think is going to be a much more common occurrence, particularly in the West. And during that, 150 million trees died in the Sierra Nevadas. And much of that is due to the fact that the drought initially triggers stress within the trees, but the actual mortality agent is bark beetles, which come in and finish off the trees. They can sense the stress in the trees and then burrow in and lay eggs within the below the cambium of the trees. And the interesting thing about pests and pathogens, but particularly bark beetles, which are a significant source of mortality, is that they're host species specific. So a mountain pine beetle, which is what was causing most of this mortality, only attacks pine trees. So if you plant all pine trees, you're obviously making the beetles very happy, but not necessarily the future of the forest very happy. And finally, another thing I would point out here is that given the size of the acreage that we need to replant, as Sonya was pointing out, we now have wildfires in California which exceed 1 million acres in size. We really have to consider an approach in which there's some level of triage to planting to try to efficiently allocate our planting resources, both in terms of money and in personnel. So this is just a schematic showing that in areas close to green trees that might naturally seed, you might let those areas seed disperse from the green trees and naturally regenerate. In the blue zone, you might actually do this combination of cluster planting and regularly spaced planting that's in sync with resource availability like wet sites. And then in remote or difficult and steep and inaccessible areas, you might use something called a founder stand, which is planting a group of trees in a strategic location in which they're well positioned to spread their seed and basically reforest the area through natural seed processes. And finally, I'd suggest that for a healthy forest ecosystem, we also need to think about reestablishing the processes which strongly influence these systems. And in much of the West, that is frequent low-intensity surface fire, which has always had the benefit of selecting for species that are better adapted to fire, such as pines, but particularly individual pines that have thicker bark. One of the things that fire does very effectively is provide a selective pressure, which means that you weed out the trees with thinner bark that have branches low to the ground that are more susceptible to fire, and fire is selecting for individuals that are more resistant to the stress of wildfire. Thank you.
Great, thank you so much, Malcolm. And then our last speaker is Eric Sprague from American Forest.
All right, am I unmuted?
Yeah, we can hear you.
Good morning, everyone. Sorry for that challenge. One more moment here. Let me get this slide up. Everything seemed a little slow. All right, well, good morning. I want to take a few moments to step back out a little bit, introduce you to reforestation as the practice, why we do it, and how does it look across the landscape, and then review some of the opportunities and barriers facing us as we go back to work today and start thinking of how do we scale this up? How do we meet these needs that and challenges that both Malcolm and Sonya have brought up today? Some of what I say, I think, will reinforce what you heard in earlier presentations, but also help expand it to other parts of the country. Well, when you think of reforestation, you likely think of large landscape plantings like this longleaf pine planting on a Florida state forest, or this community planting that happens across the country. But it can look different depending on where you are and what objectives you have. Reforestation can be used to restore ecosystems, like this former mineland site on Monongahela National Forest. When this site was reclaimed in the 70s, it was planted in dense non-native grasses and trees to control soil erosion. Well, 40 years later, it looks exactly the same. The reclamation worked too well. So reforestation can come in instances like this, loosen up the soil, and reintroduce native species like red spruce. After fires, reforestation can help to quickly establish trees to protect soil and water resources and jumpstart carbon sequestration, like this site in Northern California. And while too much fire can lead to reforestation opportunities, too little fire can as well. A lack of natural low-level fires across the eastern United States is reducing the prevalence of species like white oak in favor of shade-tolerant species like maple. Prescribed fire can be used to stimulate the natural regrowth of white oak by providing more light to the forest floor. Reforestation can also be included as part of a management system to provide a range of benefits, like this photo of a jack pine planting on Michigan State forest lands. The newly planted forests are harvested at regular intervals to provide early successional habitat for the conservation-reliant Kirtland River. Reforestation can happen across ownerships like this former fruit and vegetable operation on the Lower Rio Grande National Wildlife Refuge in South Texas, and on private lands to protect water quality on farms like this Pennsylvania pasture. Now, Sonya and Malcolm both got into this, but it's worth dwelling on it again because it's so important to our conversations. But why are we reforesting anyway? Forests obviously have been around for a very long time. They've evolved for millions of years to regrow after disturbances. Wind and wildlife disperse seeds to open areas where they establish and grow. You can think of maple seeds twirling to the ground, or blue jays caching acorns. When they can't find all of them, some of them sprout into new oak seedlings. Species like oak can even sprout from the root system after fires. Well, there are three reasons that I want to come back to on this slide. The first, we just saw a couple good reasons in the last slide. Reforestation can be used to restore degraded habitats like former mineland, longleaf pine, and oak forests that would not recover on their own. Second, as we heard Sonya mention, climate change is leading to widespread regeneration failure across the West. High temperatures are preventing seeds from germinating, extreme drought prevents seedlings from getting the water they need, and large and high intensity fires are burning seed beds and seed-bearing trees. For example, in the area in this photo, laxally growing ponderosa pine 6 years after the 2011 Los Conchas fire in northern New Mexico. And lastly, because these changes are happening so fast, forests don't have time to adapt. So with reforestation, we can reintroduce species and genetics, and maybe even planting design, like Malcolm talked about, to better adapt future conditions and create a more healthy and resilient forest of the future. Well, one of the first questions asked as the Trillion Trees initiative started globally and here in the United States, and was 1T.org got up and running, was, is there space for billions of trees across the country? Well, the short answer is yes, there's a massive opportunity. Susan Cook-Patton and her team at the Nature Conservancy assessed potential for forests to be established where they occurred historically. After accounting for a number of factors, including harvesting and natural regrowth, she found up to 133 million acres of land suitable for reforestation in the lower 48 states. This is equal to 68 billion trees. Opportunities are mainly driven by post-fire in the West and pasture in the East. This is the best nationwide and wall-to-wall consistent data set on reforestation potential in the United States, and can be viewed as sort of an upper bounds of potential. You know, whether a specific site has potential or not depends on a lot of factors, like whether it fits into landowner's goals or not, or whether the site's actually accessible to tree planters. The U.S. Forest Service, this analysis shows around 7.4 million acres of opportunity on U.S. Forest Service lands, while field assessments by the agency show around 1.3 million acres. So a big discrepancy there. And part of this can be explained by those site level considerations. But I do think one of the benefits of this data is that it allows the Forest Service and partners to come together to refine and target where reforestation opportunities exist across the national forest system. To help with that, American Forest and TNC teamed up to develop the Reforestation Hub to guide reforestation initiatives. The hub allows you to view reforestation opportunity data for your county, state, and region, and you can sort the data by a variety of fields, including carbon sequestration potential, ownership, and land types like floodplains and wildlife corridors. Please check it out at reforestationhub.org and tell us what you think. Well, if where can we plant billion trees was the first question. And certainly the next couple of questions were, where will all those trees come from and how we plant them all? How do we scale up our current efforts to meet that challenge? Well, to answer that, we need to look across the reforestation pipeline. That is from seed collection and storage, nursery infrastructure, outplanting or tree planting, and post-planting maintenance and monitoring. Over the next couple of slides, I'll introduce you to each one of these pipeline sections and some of the challenges we face when ramping it up. It is important to note, and I'll keep coming back to this, but while tree planting might be the most visible part of this pipeline, it's just one step. And to be successful, to meet those goals that Malcolm talked about and Sonya talked about, we have to invest in each one of these sections. Well, not to be too glib, but reforestation starts with seed, of course. And outside of regions with a strong forest products industry, there is insufficient investment in collecting and storing seed. This is particularly true for reforestation and restoration focused species or climate adapted seed. Malcolm talked a bit about the lack of diversity in plantings. We're seeing this in seed collection as well. We don't have the diversity of seed to meet some of those goals that we're setting for ourselves. Some of the reasons for that and challenges we see are seed collection requires skilled seasonal labor that can be tough to find and maintain over time. And once seed's collected, we need infrastructure like cold storage and extractories to process and store that seed. So both barriers will need to be addressed to increase supply of seedlings over time. The Reforestation Hub identified an opportunity to reforest 68 billion trees across the country. If we set a goal to meet half of that by 2040, so around 34 billion trees, nurseries would need to produce an additional 1.8 billion seedlings each year. America's tree nurseries currently produce 1.3 billion seeds annually, so this requires more than a doubling of current capacity. Existing nurseries have the ability to scale up and could potentially meet 80% of this need, but to meet that gap, extra neat seedlings would need to come from a couple of strategies. One would be enhanced regional sharing and building new nurseries. Regional sharing is important as 90% of the ability to increase nursery capacity is located in just two regions, the South and Pacific Northwest. Right now, different regions do source seedlings for planting projects in other regions. For example, trees grown in the U.S. Forest Service Coeur d'Alene Nursery in Idaho can provide seedlings to projects all the way to New Mexico. So expansion of this regional sharing of nursery capacity may be needed. Additionally, new nurseries will be needed in regions with high reforestation opportunities, but limited ability to scale up, including the Southwest. Nationally, workforce limitations are the top barrier to expanding America's nursery infrastructure. Expanding seed production will require a growing labor pool across the pipeline, from tree climbers to collect seed, to nursery managers, to people planting in the field, to those who can come in and do the follow-up maintenance. While that may seem daunting, this is a significant opportunity to grow jobs, especially in rural areas where nurseries and some of this work often happens. Another interesting challenge is that public and private nurseries operate with a closed-loop business model, and that they rely on seedling sales to finance infrastructure investments. This is a challenge more and more these days because reforestation demand is becoming more difficult to forecast, given increased mortality from severe fire, drought, and pest and pathogens. So assuring nurseries of long-term demand of seedling will be critical to having them get the signals they need to invest in their infrastructure. And as we discussed earlier throughout this talk, climate change, pests and pathogens, and other threats are challenging our current reforestation approaches, so we need to innovate as we go. So more investment in research is going to be key. One interesting example that's coming up, for example, is that Dr. Owen Burney at New Mexico State University has found some success with what he calls his tough love strategy of limiting water to seedlings in the early stages of their growth, and that makes them more drought hardy when planted out in the field when they experience some extreme drought weather that they're seeing. So earlier I noted that tree planting was just one part of the pipeline, and this is true even within its own section of the pipeline. For example, if we suddenly had sufficient funding for tree plantings, we wouldn't have the projects ready due to backlog of national and state environmental reviews. This is particularly true for the U.S. Forest Service and Bureau of Land Management. More planting capacity is going to be key to scaling up. Additionally, whether planting in pasture land or post-fire, we must control competing vegetation to have any chance of success. Shrubs, grasses, and vines can smother seedlings. A key step in preparing for tree planting is to develop planting plans. Plans include identifying appropriate sites, For example, focusing tree planting only where natural regrowth is not expected, ensuring species diversity. Malcolm talked well about this in the West. I'm talking to you from Maryland, where there are many mature riparian forest buffers that were put in to help with stream habitat goals and water quality issues. But many of those are dead and dying because they were planted heavily with ash trees. The emerald ash borer is causing widespread damage to ash trees throughout the East and forcing us to go in and deal with those dead trees and reinforce the plantings with other species. So more species diversity is a key lesson across the country. And then you can use planting plans to help manage your design and your strategy for planting. Malcolm talked a bit about this, but also when you think about habitat, think of the Kirtland's warbler, jack pine planting picture I showed you earlier. Planting design includes dense plantings of up to 1,400 stems per acre, then with regular openings to meet the habitat needs of the Kirtland's warbler. So planting plans pull all this together, require capacity to do that and to be ready when reforestation opportunities arise. We've talked a few times about the challenges that climate change pose to reforestation, but we can use climate science to lessen those risks and build a more resilient future. This includes selecting species that are better adapted to future climates, ensuring resilient genetics and specialized planting techniques, including cluster designs or nucleation that mimic natural regeneration. And finally, not a surprise if you're paying attention, workforce capacity constraints need to be considered when scaling up reforestation projects. The majority of planting crews consist of migratory labor and rely on H-1B visas and subject to labor and immigration policies. So something we'll have to keep an eye on as we continue our goals to scale up reforestation. Well, a couple more slides here, but I want to sort of stop and say, all right, we're at the point of the pipeline, we've got trees in the ground, we're done, right? No, I'm hoping you're all shaking your head no. We cannot plant and walk away if we want those trees to grow into the next forest we want. But it's a common trap we all fall into for some very common reasons. But the first 5 years are critical to establishment for those new seedlings. So short-term maintenance is required. This starts with regular monitoring to evaluate survival. If we find that vines, shrubs, or other competing vegetation is beginning to become a threat, then we got to go in there and do some competition control with either manual removal or herbicide. Deer and voles can kill plantings overnight. Yes, I still have some scars of this. Sounds like Sonya, you do too, and I bet many others on this call who are gardeners that do as well. So tree shelters and other strategies can be used to manage this, but they do get knocked over by wind, depending on where you are, by lawnmowers. So those do need to be maintained over time and straightened up. Research is showing that seedlings of some trees, like the whitebark pine, are more successful in the shade of downwoody debris. And so many projects now include the use of microsites to improve success. Training contractors on the use of microsites can be challenging, so short-term maintenance after these can be really important. This is one of my favorite photos. It's Carl Anderson on the Flathead National Forest. I was out there with him and he's moving this log just a couple inches to give this whitebark pine seedling a little more shade. Maybe an extreme example, but I think it shows you sort of the need you need to put into some of these microsite plantings. And then depending on objectives, long-term management is going to be important too. We heard Malcolm talk a bit about this. If you're planting densely, we know we need to come back and thin over time to increase resilience of that stand. And then over time, reintroduce low intensity fire to maintain that landscape. But across the country, long-term maintenance is needed too. Longleaf pine, of course, is a fire-dependent landscape. We've got to continually run fire through that landscape. Oaks need disturbance to thrive, so we've got to continue to come in and open up the canopy, whether through prescribed fire or other strategies. So long-term management can be very key to some of the goals of different plantings we implement. But of course, funding and capacity gaps are a key struggle here, as Malcolm talked about. We often don't have the money to go back and implement this, and that has big implications for the goals we're trying to achieve. Well, just to reiterate again, the reforestation pipeline in its totality is important. We need the seed, we need the nursery, we need the outplanting, but if we don't come back and invest resources after planting, all those previous resources may be for naught. And so the whole pipeline is critical, and sort of the key lesson I want to leave you with today. And then it's just to sum up, there's some resources out there that I think could be really helpful to you as you think through different strategies for scaling up reforestation. Just released paper by Joe Fargione and 18 other folks, including a few of my colleagues, on the challenges to the reforestation pipeline. And I can work with the team to make these available to you as well. American Forest followed up with a number of nurseries across the country to assess regional nursery capacity barriers and opportunities. So we have a number of fact sheets and additional data sets on the situation you find across the country. And then we have taken a start on pulling the key findings of those two documents into a policy guide with some key strategies that we think we need to think about as we begin to scale up. And you can find that on American Forest's website, this Ramping Up Reforestation Policy Guide. And then point out for technical resources, US Forest Service Reforestation Nurseries and Genetic Resources, the Ringer program, is a great place to go to for some technical information and latest information that we're finding in the field. So thank you.
Great, thank you so much, Eric. We actually have sort of run out of, but maybe we can have an opportunity for one question. Unfortunately, Sonya had to run off to a meeting this morning, and so she will not be able to stay with us, but Eric and Malcolm, the one question I thought would be of value to this group would be, you've talked about both challenges and opportunities, laid out some issues that need to be dealt with, but maybe you could just say, put a fine point on what is the most critical missing piece from your perspective. And Malcolm, maybe first you and then Eric, and then we'll close the event.
Great question, Ann. Surprisingly, I'm going to say that there's a fair amount that we need to know if we're going to reforest in this new world in which there's challenging climatic conditions and fire conditions. And I know this is a cant response by a researcher to say that we need more research, but frankly, we know very well how to plant trees, the pines and lines approach. We have much to learn about how to plant them effectively when we're using this variable planting of openings and clusters of trees. So to my mind, one of the largest gaps that we really have is a better understanding of how to reforest in a new world with new stresses and conditions from wildfire and drought.
Yeah, and I'll build on that just a little bit in that there's a real urgency to figuring that out quickly. Of course, research takes time, but I encourage us to think through how we can learn that as we go. Let's start implementing research designs into the projects to begin treating our forests and thinking of the future as we go now. So just sort of learn as we go, I think is going to be key requirement for us here. And then a couple more things, just on the seed collection side, we're going to need to begin collecting and improving the stores of a diversity of seeds to meet these reforestation goals. And then also need to begin thinking about, are there business models that we can help nurseries think through to give them the assurances that they need to begin scaling up infrastructure, maybe long-term contracts or other innovative financial models we can come up with to help scale up capacity.
Thank you thank you both for your responses. I do think we need to end this morning's event, and I appreciate everybody who participated. We will make the PowerPoints available to the participants, and that will be handled through Michigan State University, the FCCP program. And again, thank you all very much for joining us. Hopefully you'll join us in the next of these events, which should happen in a couple months, where we're still trying to determine what would be the best topic. And if you have any thoughts, please let us know, because this is really designed for you who are working with congressional offices and the staffs and pending legislation, and what do you need to be successful? So that's what we're here to do. Thank you very much on behalf of the Forest Climate Working Group and all the member organizations. Have a good turnout on this sort of gray day in Washington, D.C., and look forward to having you join us next time. Thanks so much. Have a great day.
Thanks, Ann.